Like to see something amusing? In a moment, two men, a scientist and a writer, are going to rehearse a weather program. The story of weather, they call it. But what do humans know of weather? I am weather. I, Meteora, goddess of weather. Let's watch them make fools of themselves.
All right, Jim. Open your screen. Well, the technical department's ready. How's the script?
Still pretty much of a shambles, I'm afraid.
Better unshamble it pretty soon. Television doesn't wait for anything. We need at least one rehearsal.
Yeah, I know, but I've got so much material.
What use are you going to make of your magic screen this time? Any ideas?
Well, I've got one. Let me try it on the screen once more. Magic screen doesn't seem to get it. Nothing shows up.
Well, that's the way with imagination sometimes.
Hey, Doc, what's that gadget?
Oh, this is called a drop sonde.
A drop what?
A drop sonde.
What's it for?
Well, it's dropped from an airplane, and it radios back pretty complete weather information to the mother plane.
Yeah, pretty neat.
Certainly is.
Oh, say, sky waves and sky rivers, that come under prediction?
Yes, down toward the end, I think. About where the electronic weatherman is. I thought you said your magic screen was blank.
I did.
Take another look.
What have I dreamed up this time?
Didn't I tell you they were going to make fools of themselves?
Sky Rivers!
Weather experts.
Quiet.
Electronic prediction.
Now, scram, whoever you are. We got a television show to rehearse. Quiet.
You dare thus address the weather deities, mortal?
Weather deities?
I am Meteora, supreme goddess of weather, and these are my attendant deities. Cirrus, the cloud god. Boreas, god of the winds. And the triplet gods, the Marutas.
I'm rain.
I'm snow.
I'm hail.
Do you think this could be something I ate last night? Now, look, if you guys think you're going to clutter up our program with superstitions and dreams, legends...
Legends? You call us legends, mortal? Why, if it weren't for us, you'd be speaking Spanish right now.
Spanish? Is that so, Doc?
Yes, that's right. It's quite possible a tremendous storm saved England from the Spanish Armada.
What I did to those ships. Wrecked them.
We could give you 1,000 examples of where my whims have changed man's history.
But only a Homer could write them.
Homer? Doc, I think I'll turn in my typewriter.
A Meteora. The tale of your effect on man is a long one. But what we're interested in is the why and how of your activities. The truth about the weather.
Truth? You guys calling me a liar when I say I blow to please Meteora?
That's not why you blow, Windy.
Windy?
No, it isn't. The real cause of wind is the sun.
Here, I'll show you. Jim, let's have roll 2, general circulation.
Coming right up.
Now, anybody who's ever lived in the tropics knows that around the equator, the Earth is like a stove, heated by the sun year in and year out. And over this giant stove warm air is constantly rising. But near the poles, the Earth's like a cake of ice, frozen year around. And over the poles, cool air is constantly falling. Now, watch what comes out of this up and down air. The cold air moves toward the equator to replace the rising warm air, and the warm air moves high up toward the poles to replace the sinking cold air. Two big loops of north and south winds encircling the Earth.
And that is wind?
What's more, they keep the Earth green and warm, bringing rain from the oceans and heat from the tropics. If the sun were to fail, all the winds of the world would die away in a few weeks, and our planet would be finished.
Now, wait a minute. Everybody knows I don't just blow up and down and north and south. I blow east and west, too.
Sure, but I'll give you odds you don't know why.
Why? Why, because of Meteora.
Wendy. Meteora's not the answer.
Do you know the answer?
Well, I got a friend who does. Like to drop in on a carnival and meet him?
A carnival?
They've lost their minds.
Oh, carnival! Oh, I like carnivals.
That carnival belongs to my friend, Professor Coriolis. And that's his carousel. Oh, Professor.
A moment, please. I am at your service. 2 tickets? No?
No tickets, not today.
Tomorrow, maybe?
Well, maybe. What we're interested in right now, Professor, would you explain to us why wind blows east and west as well as north and south?
With pleasure. To show this, I must use the carousel. Attention! Now you must get on the carousel with the children. Now I give one child a ball. So. Easy, no? But see what happens when I start the carousel? Pierre. Now.
But the ball curved.
Naturellement. Now let us watch the same action once more. Only this time we slow everything down. Missed again.
You see? It did curve.
Aha! You think so? Come, we find out. But this time we must get off the happy-go-round. Now we observe the exact same throw once more. Pierre, whoop! It never curved at all, did it?
I don't believe it.
What happens is I show you very, very slow. The catcher is moving with the carousel. So the ball missed him. But remember, when you were on the carousel, it looked like this.
I begin to see. When you're on the carousel, it seems to curve. When you're off it, it doesn't.
That's right, that's right. And now I take you to the biggest carousel of all, the spinning Earth. If we take the part north of the equator and tilt it a little, we have a carousel which turns counterclockwise to the left. So for you on this carousel, like the little boy on the happy-go-round, everything curves to the right in the northern hemisphere. You do not believe me? Eh bien, suppose, please, that I am on the North Pole. I am lonely, and I wish very much to see in New York my friend, Fifi. Coming, Fifi! Ah, no!
As the professor found out, to someone on Earth unaware of its motion, the rocket will curve to the right.
But to someone out in space who can tell the Earth is rotating, this is what it looks like. The rocket goes straight, but the Earth is spinning. But since we're not in space, for us in the northern hemisphere, there's this curve to the right for anything that moves. Gunners must adjust for this apparent curve. Transatlantic planes would get lost if their navigators didn't correct for the effect. Even migrating birds have some mysterious built-in mechanism which corrects for it. And so you see...
Pardon, monsieur. You have overlooked the best example of the drift to the right. The wind. This whole affair is called the Coriolis effect. Merci bien. I trust I have made all this quite clear. Au revoir, mes amis.
Well, if it isn't quite clear, let's examine our wind loop again. See what happens when the Earth begins to make like the professor's happy-go-round. The big loop becomes 3 smaller loops. Now, so we can look at them, I bring the carousel to a stop just like the professor. This loop by the equator is just a smaller version of our original one. But the southbound air close to the ground, swung to its right by Coriolis, begins to blow from the east. Isn't that about it, Doc?
Yes, that's right. Creating the trade winds that sailors used for centuries to circle the globe.
Now, loop number 2. Here the air near the ground moves north because... Doc, maybe you better take over, huh?
Well, this reverse loop hasn't been completely explained, but it's easy to see that lateral friction due to large-scale turbulence, the transport of angular momentum, conservation of potential vorticity, as well as baroclinicity in the frontal zone.
Doc, let's just say the loop is there, huh? And that the northbound air near the ground is swung to its right and begins to blow from the west,
creating the prevailing westerlies.
And finally, the cold sinking air in the third loop, equator bound, is swung to its right to become the polar easterlies. There you have it, folks, from the Coriolis merry-go-round to the general circulation of the atmosphere.
And this is actually how wind is made?
Well, yes. In general, wind is created by the sun and given direction by the Coriolis effect.
Boreas? For centuries you've been telling me you control the winds.
But I do, Meteora. There's more to it than that.
Oh, yes, there is. We know that there's secondary causes of wind, land and sea, for instance.
Ask them why I blow in 2 opposite directions on the same day in the same place.
Well, that's an easy one. Now, land heats and cools rapidly, water comparatively slowly. This causes wind. Summer sea breeze is a good example. Now, under the daytime sun, the land back of the shore grows warmer than the sea. And cool air flows from the sea to replace the warm air rising over the land. At night, when the temperature inland falls below that of the sea, the flow's reversed. The breeze changes and blows off the land.
Yeah, and of course there are other secondary causes of wind. Wrinkles in the earth, the mountains and valleys making up and down drafts and causing such winds as boras and bergs. And local heating and cooling, making, well, harmattans, purgas, konas, dust devils. You name them, and the doc will explain them.
Well, Boreas?
What can you say of clouds? Of the glorious masterpieces I create? Exquisite. And only one of the thousands I can produce from my palette.
Do you know what's on that palette of yours, Curly? Dust. Plain, ordinary dust.
This is really too much.
You can't mean dust.
You heard right, Meteora. We do mean dust. Dust and water. Let me show you the prescription. Mr. Apothecary. Mr. Apothecary. Mr. Apothecary.
Yeah?
How's to mix us up a cloud? Rush order.
How's that?
A cloud.
A cloud? Won't take a minute. Yeah, the cloud. Let me see here. Cloud. Cloud, here it is. Pound of pure air. And, add water vapor till humid. Where did I put that water vapor? Oh, yeah, here it is.
What's water vapor?
Just water in the form of gas. Now, most air has water in it, even though you can't see it.
No interruptions, please. Mind your manners. Add water vapor, just short of saturation point. And now the final ingredient, cloud dust.
There's no such thing as cloud dust.
Oh, yes, there is, Curly. You can't see cloud dust any more than you can see water vapor, but the air's full of it.
We live in a perpetual dust storm without knowing it. Salt crystals from the sea, ash from fires and volcanoes, exhaust products from automobiles and factories.
Cloud dust, just like I told you. One pinch, then cool.
And it's when air is cooled that dust makes clouds possible. The excess water vapor, millions of water molecules, keeps fastening on to the bits of dust until they become visible cloud droplets.
A cloud, just like I told you. Now here's a prescription if you want to make up a cloud to hum. You mix air, water vapor, and dust. Chill thoroughly, and there you be.
Artist, indeed. And where do you think you're going?
We have work to do, Goddess. The fields need rain. The mountains know.
Rain and snow, make 'em feel in a snippet. Exactly the same ingredients as in my cloud prescription. Air, water vapor, and dust. Only much colder this time. I'll use the precipitation machine. Now, watch closely.
When the temperature is considerably below freezing, first thing that happens is that these tiny water droplets surrounding this dust particle freeze. But all of them grow bigger and bigger by taking water vapor from the droplets around them until they start to fall. Some merge with other crystals. Some catch still other cloud droplets. And soon they become the big ice crystals we call snow.
Yeah, wintertime it stays snow all the way down. But in summer the snow melts and becomes rain.
Rain am really snow?
Well, got any other prescriptions you want filled?
No.
No? Thank you, Mr. Apothecary.
No trouble at all.
If only Thor were here, he'd silence them.
Thor?
Thunder and lightning.
Thunder and lightning? The doc knows all about them.
Wait a minute, all about's a big order. Of course, everybody knows that thunder and lightning are associated with thunderstorms. Now here's a time-lapse film of a big one. Warm air pushing up through a fair weather cloud called cumulus is the fuse that sets off thunderstorms. The cumulus grows explosively, sometimes rising more than 40,000 feet in less than 10 minutes. The height of its growth, the characteristic anvil top forms. Turns into a cumulonimbus or rain cloud.
And comes the deluge.
Now let's see how these fireworks start. In a cumulonimbus, positive charges tend to accumulate near the top of the cloud and negative ones near the bottom, forming reservoirs of positive and negative electricity. It's also believed that electricity generated by wind-shattered drops, by friction between ice crystals, by the freezing of drops, is added to these reservoirs.
Anyhow, when they become overcharged, something's got to give. When you see lightning, it can be within a cloud, or between clouds, or between the earth and a cloud. And what you hear, merely shock waves caused by the sudden expansion of air heated by lightning. Same kind of waves are sent out by exploding dynamite. To the eye, lightning looks like a single stroke, but it's really a series of strokes. These pictures, taken by a camera developed especially to photograph lightning, show several distinct strokes in a single quarter-second flash.
As high as 40 strokes have been recorded in a single flash.
Who said lightning never strikes in the same place?
Well, man's almost been able to do the trick. Here we're going to show you some tame lightning that always strikes in the same place.
Make lightning, will they? Just lead me to them. Here comes Thor. He'll show them.
Yes, Thor!
Where are they?
Right there, Thor.
Humans?
All of you, make a storm! A thunderstorm!
I'm afraid that's quite impossible. No thunderstorm today.
Show the mortal how wrong he is.
Neither rain, nor snow, nor sleet shall stay this flame.
I'll marry the god who puts that candle out.
I'll blow it out.
I'll show him.
Imposters, fakes, charlatans, all these years.
Don't blame your gods, Meteora. They've been very real to us, even though we created them to hide our fears of the unknown.
I'm so confused. Am I real?
Oh, yes. Weather's very real and difficult to understand.
Oh, but you do understand me. You're the only one.
There's something phony here. How'd you know it couldn't storm?
The forecast from the Weather Bureau. Say, and that should interest you, Meteora, because the Bureau's got the largest staff of weather psychiatrists in the world. You like to see the clinic they've set up at Suitland, Maryland?
A clinic for me, Mr. Scientist?
Call the National Weather Analysis Center, operated by the United States Weather Bureau.
More than 200 specialists working in shifts around the clock, covering present and future weather from sea level to the stratosphere, clear around the world. Each day they turn out 142 different charts. How do they do it? Well, like doctors everywhere, they get their dope directly from the patient. In this case, teletype data from the entire northern hemisphere. Humidity readings, temperature, wind velocity, air pressure, snow, sleet, rain. 375,000 reports each day from more than 5,000 different places.
The reports arrive in an ingenious code.
International weather language.
This is a typical code message. it reads exactly the same to a weatherman in Milwaukee, Moscow, or Timbuktu. Every few hours, reports are transcribed on an isobaric chart in the form of numbers and symbols.
Isobaric chart, that's a weather map to you and me. And we've got one right here. Let's use it, huh?
All right.
Here we are.
Now, any meteorologist can tell at a glance what the weather was at any point in this whole vast, gigantic area.
Told you it was a phony. All they got there is old weather.
True, Boreas, but without old weather, the medicos couldn't even make a start at diagnosing new weather.
You know, maybe this isobaric chart of yours is a little complicated. Couldn't we show them how the weather experts make a map right from scratch?
Well, let's do it.
The first step is to record all the data, like this. Next, we draw these lines called isobars, meaning equal pressure, connecting those places that reported the same air pressure readings.
When the isobars form closed curves, as they often do, the centers of the curves with high pressure readings are marked high, and the centers of the curves with low pressure readings marked low.
These highs and lows are pretty important to the diagnosis because under a high, the weather's more often than not fair, and under a low, more often than not cloudy.
But the most important thing is that air tends to flow from a high pressure area to a low one.
And what's more, highs and lows don't just stand still. Know where the highs and lows are today, and you got a pretty fair idea of tomorrow's weather 600 miles to the east.
That's right, and also of tomorrow's winds, because around a high, they invariably turn to the right, and around a low to the left. So knowing this,
Hey, wait a minute. Excuse the interruption, but I don't dig that left turn. I thought Coriolis was always supposed to swing wind to the right.
Yes, and it tries to. But because of the interaction between it and the pressure gradient force, complicated by surface friction...
Oh, look, I'm sure there's somebody that understands that, but in order to make it clear to Meteora, don't you think we ought to see if Professor Coriolis himself is still around? Professor Coriolis?
At your service, mes amis. The matter is really quite simple. If we think of the high as a mountain of air and the low as a valley, air flows down off the mountain, as I will demonstrate. Like the air, I start straight down off the mountain, but the Coriolis effect turns me, and I spiral to the right. It is like champagne, you know. Now the valley. Again, like the air, I start straight down into the valley. And again, Coriolis turns me. But what has happened? Aha! I will tell you. I cannot keep turning to the right because that takes me upward. So I must resist the Coriolis pull and turn to the left. Aha! There I go. Left and left and left until I am at the bottom. It is clear, no? Adieu.
You know, if Professor Coriolis stays around long enough, I might even turn into a weatherman myself.
Well, he hasn't explained everything quite. There are a lot of things. Battlefronts, for instance.
Battlefronts in weather?
Oh. A group of Scandinavian meteorologists made an amazing discovery toward the end of World War I.
Found a far bigger war right over their heads. A war between giant air armies from the north and from the south.
Called air masses by their Scandinavian discoverers. In the line of their collision, a front. Battlefront, if you like. Worldwide research on the air mass theory, first presented in 1919 in a paper written by Jakob Bjørknes of Norway, spokesman for the group, has revolutionized weather forecasting.
And what happens to weather when these armies march has been pretty well doped out, too.
Let's look at our original map again. Now, that line being added is the weatherman's way of marking a cold front. It's located, like all fronts, mainly through abrupt changes in temperature. And it means that the cold air army is pushing under the warm one.
Here's a cold front and its special brand of weather. Wind squalls, thunderstorms, followed by rapidly clearing skies. Oh, the new line's a warm front. Generally brings long, slow rains, light winds, and skies that may stay overcast for days.
Of course, this is a very simplified version of a real weather map.
Yeah, about like a newspaper weather map. Which, by the way, with a little practice, you can use to make your own predictions.
Hey, maybe we could get jobs at that clinic they were talking about.
Be a breeze, knowing what we know.
Don't kid yourselves, fellas. Compared to the chief forecaster at Suitland, you know from nothing. Doc, give him a rundown on what he has to know and do.
Well, briefly, what the forecaster does after he gets his far more complicated map showing how the weather was a few hours ago is to compare it with a dozen others, maps for the last few days, charts of surface and upper air winds, of pressures at 7 different levels from sea level into the stratosphere. He then evaluates the force of the westerlies and the trades, the position and strength of highs and lows, past movements and present characteristics of fronts and the air masses behind them, and interprets all these things in terms of atmospheric dynamics, the general circulation, cloud physics, turbulence and friction, solar and terrestrial radiation.
And then adds a couple of pinches of intuition and inspiration and comes up with a bulletin on how the weather is going to be the day after tomorrow. Well, you guys still want that job?
Well,
Of course they don't.
yeah, but how often are these forecast guys right?
You do half as well at the track and you'll be a millionaire.
Well, you don't say.
Nowadays, the weatherman's right in 6 out of every 7 forecasts.
How wonderful. It's such a lovely, warm feeling, Mr. Scientist, to be understood, even when I'm temperamental.
Temperamental? You can say that again. Hey, we've got some new film of one of your worst temper fits, what we call a tornado. When one of these strange aerial monsters goes on the prowl, nothing above ground is safe. In the center of that ugly whirling funnel is an incredible weapon the equal of which it would take a science fiction writer to dream up. A vacuum so powerful it turns buildings into actual bombs which explode. Outside the funnel, believe it or not, winds up to 600 miles an hour. No wonder it can rip apart entire towns.
Each year, tornadoes, which have appeared in every state, take scores of lives and damage millions of dollars worth of property. Tornado experts have pretty well decided they're formed in exactly the way thunderstorms are, but with a cool, dry layer of air aloft, which makes for greater instability, and a strong wind high up to trigger the violent spinning action that becomes a tornado on land, a waterspout at sea.
And out of the how of these whirling dervishes are coming the answers to the multi-million-dollar questions, where and when.
Weathermen are at least making a start at tornado prediction.
And maybe the answers aren't too far away. These meteorologists don't just guess. They know quite a lot about the behavior of tornadoes and their paths.
Fascinating.
Oh, and wait till you hear what they've done about your all-out 2-week tantrums.
The most dreaded of the world storms, the hurricane. Jim, the world map. Now here are the main hurricane paths of the world. Notice how they all begin within 15 degrees of the equator.
Hey, I never realized that before. How come?
Well, nobody really knows. In fact, nobody really knows how hurricanes are born or why they become so intense. In general, they start in regions where widespread easterly trade winds develop waves. And occasionally one of these waves turns into a spinning vortex. And the inflow into the center produces heavy rain, which releases energy, causes the air to spin faster and faster as it nears center, just as an ice skater spins faster when she draws her arms in toward her center. A young hurricane born, well, let's say off Barbados in the West Indies, and in late summer or fall, peak hurricane season, first drifts northwest at about 10 miles an hour, even though its own winds are circling around its center at 50 or 60 miles an hour.
And it's about this time on the second or third day that as rugged a group of weathermen as you'll find anywhere comes into the picture. The hurricane hunters from Kinley Air Force Base, Bermuda.
These hunters locate their aerial quarry by radar. Its spiraling clouds show up over 100 miles away. Then they fly around it to see how big it is and where it's headed.
But just looking at this incredible wind machine isn't all the hunters do. Believe it or not, to find out how strong it is, here they go, right into the middle of it. Now, if the plane sticks together, they're coming to the most fantastic thing of all, the hurricane's eye.
In the center of every hurricane is this mysterious eye, ranging from 5 to 40 miles in diameter, where the air is calm and the sky, as often as not, a cloudless blue. No trouble for airplanes here. Seabirds sometimes fly in the eye for hours to avoid the encircling winds. Now, while the hurricane hunters are making the first of many reports on our particular storm, let's go to receiving headquarters, the Joint Warning Center at Miami. Here, Air Force, Navy, Weather Bureau hurricane specialists plot the path of this oncoming giant. Navy weather planes have been called in on the chase. Coastal radars from the tip of Florida to New Jersey are all keeping watch.
And by now, Maggie is front page news.
Maggie?
Don't look at us. That's the Weather Bureau's idea, giving hurricanes girls' names.
How clever. Perhaps you'll name one after me someday, Mr. Scientist.
Let's just stick with Maggie, huh? Only 6 days old, but practically full-fledged now. Winds up to 100 miles an hour over an area 200 miles in diameter and getting dangerously close to land. What's going to happen? Will she swing northeast, caught by the prevailing westerlies, as most hurricanes do? Or will she hit land, as an average of about 2 a year do? And if so, where and when? Tough questions. Because if a hurricane warning goes on the air, whole communities are thrown into complete but controlled turmoil. Barricades go up, schools close. And then if the hurricane veers off...
We are interrupting this program for a special bulletin.
The Weather Bureau has announced the hurricane due to hit today has changed direction. Hurricane warnings for this area have been canceled. However, small craft warnings...
Everybody's mad at the weatherman. But if a warning is not broadcast and the hurricane does hit, hundreds of lives and millions of dollars can be lost.
Tough questions indeed, and time's running out. Every last-minute factor is weighed. The decision is reached.
Hurricane warning.
Minor Weather Bureau advisory number 14. Hoist hurricane warning, 5 p.m. Eastern Standard Time.
Hoist northeast storm warnings and maintain a hurricane watch.
Hurricane Maggie is now approaching San Salvador and the northern Bahamas. All precautions for the protection of life and property should be begun at once in the area of hurricane display.
And Maggie's well worth a warning. Here's where she hit land. 135-mile-an-hour wind.
More energy being released every second than from a dozen atom bombs, which gives Maggie a terrific punch.
Power systems are knocked out.
Along half the Atlantic coast, ships fight for their lives.
Streets flooded with tons of rain.
Entire cities paralyzed. By now, Maggie's being tracked by a second group of experts in the Washington, D.C. Hurricane Warning Center at the Weather Bureau's airport office, with the same big problems as the boys in Miami. And don't think John Q. Public isn't worried, too. The New York Weather Bureau's automatic answering service took over 400,000 telephone calls the day Hurricane Diane roared by in 1955.
Hurricane Diane is moving northeastward and will pass over the metropolitan area on Friday. Rain could be heavy and cause flooding in some places. Hurricane Diane is moving northeastward and will pass over the metropolitan area on Friday.
Finally, like old soldiers who just fade away, Maggie just blows away, out to sea.
Leaving behind $235 million worth of damage over a 500-mile wide path.
But only scattered casualties, thanks to the weatherman's warning.
This is beyond anything I ever dreamed of. Even in my vilest mood, you still understand me.
Anybody know the address of the old god's home?
Actually, Meteora, we've hardly begun to understand you. But man working with cause and effect, adding new methods of observation, and new knowledge as he discovers it is coming closer and closer. Even now, in the field of prediction, amazing advances are being made. In the numerical weather prediction unit at Suitland, the giant electronic weatherman daily absorbs weather data from halfway around the Earth in the form of specially prepared punch cards. And in 2 hours, using complicated hydrodynamic equations that would take a human forecaster a lifetime to solve, comes up with prognostic charts.
Which, believe it or not, it draws itself.
This line being sketched in around the dark areas, supplied by the machine, is an isobar. These isobars show the predicted pressure distribution for the continent. Now stamped in are the resultant highs and lows. And here's the machine's chart of the predicted vertical motion of the air for the next 36 hours.
Of course, this robot weatherman wouldn't be doing any of this if a couple of human mathematical wizards hadn't primed it first.
Right. The late John von Neumann, working with Jules Charnay at the Institute for Advanced Study at Princeton, formulated the equations this amazing machine uses.
And someday, a great-grandson of the numerical weather predictor, as the gadget's called, will get coded data from ultra-high-speed radio sondes zooming into the upper air everywhere, like this one, developed by the Army Signal Corps. and from a global chain of automatic weather stations being put into operation by the Weather Bureau. And then, with a few blinks of its electronic eyes, will forecast the weather for the entire world.
That's a rather distant goal. But even now, the electronic charts are at least as accurate as those made by human forecasters.
Say, speaking of human prediction, what about the extended forecast section at Suitland?
The charts these long-range seers draw under the direction of the Weather Bureau's Jerome Namias show something hard to believe. The average temperatures and rain and snow you can expect anywhere in the northern hemisphere for the next 5 and the next 30 days. The basis of long-range prediction is something rather amazing discovered about the upper atmosphere. Between 10,000 and 40,000 feet, modifying the general west-to-east flow of air, are enormous waves. Here you see a two-dimensional picture of how they surge eastward across North America, pulling down cold air from the north into their troughs and pushing up warm air from the south ahead of them. These long waves, it's now believed, cause air mass encounters, and by watching the upper air ocean, by calculating the size of the waves, their speed, weathermen can tell weeks ahead how severe the air mass storms are going to be.
Along with the waves and formed out of their central cores flows the strangest river man ever encountered, the jet stream. Bigger than all the rivers on Earth put together, this super Amazon of the heavens snakes around large sections of the globe 6 miles up in the air. Yeah, and sometimes its course is over 20,000 miles. And its top speed, well, nobody really knows, but it's been clocked several times at close to 300 miles an hour.
Actually, the jet stream rarely exceeds 150 miles an hour, but its speed varies considerably, as does its course, which may move hundreds of miles north or south in a day.
The first to discover this aerial torrent were the lumbering B-29s of World War II, which sometimes found themselves mysteriously slowed down to a crawl on high-altitude raids over Japan. But now, for hitchhiking flyers, the jet's money in the bank. Greater speeds, bigger payloads, non-stop flights between such places as Tokyo and Honolulu. Now, Meteora, maybe Doc Research doesn't quite understand you yet, but he's getting there fast.
I'm glad. I adore this, all you've done about me. But there's one question. Can you do anything to control my moods, my fits of temper, Mr. Scientist? Ooh, sometimes I scare myself.
Well, I'm afraid, Meteora, when it comes to weather control, man is still in the dark ages. A few small-scale attempts have been made. Smudge pots to save orchards from frost, fans to blow it away, fires to clear fog, and cloud seeding to make rain.
Well, that's not bad for a start.
But it's only a start. The next few years will see more progress in weather control and in weather prediction and in the use of weather than has been made since man first raised his eyes to the sky. Right now, the Weather Bureau is conducting an extensive investigation of hurricane behavior.
And what a Buck Rogers device they've developed for this. A plane drops a parachute, which in turn releases a balloon. A radio balloon that acts as a hurricane bloodhound, floats bang in the eye, and every few seconds sends out the hurricane's position by radio. This is, of course, still in the Buck Rogers stage, but with the Weather Bureau and the Air Force on the job, it won't be for long.
In addition to following hurricanes, the investigators hope to learn how to steer them.
Oh, how could you steer a hurricane?
There's several ideas, such as oil fires on the ocean, oil slicks, cloud seeding. The possibilities are endless, the unanswered questions fascinating. No wonder more and more young students are turning to meteorology.
And from these future weather wizards will come the answers to such questions as, do sunspots affect weather, changing it in 23-year cycles, as some scientists maintain? or in 88-year cycles, or even longer? What would happen if we could change the course of the Gulf Stream or the other great ocean currents, or warm up Hudson Bay with atomic furnaces?
Extremely dangerous questions, because with our present knowledge we have no idea what would happen. Even now, man may be unwittingly changing the world's climate through the waste products of his civilization. Due to our release through factories and automobiles every year of more than 6 billion tons of carbon dioxide, which helps air absorb heat from the sun, our atmosphere seems to be getting warmer.
This is bad?
Well, it's been calculated a few degrees rise in the Earth's temperature would melt the polar ice caps. And if this happens, an inland sea would fill a good portion of the Mississippi Valley. Tourists in glass-bottom boats would be viewing the drowned towers of Miami through 150 feet of tropical water. For in weather, we're not only dealing with forces of a far greater variety than even the atomic physicist encounters, but with life itself. Without air and water, which are weather,
Meteora!
man would never have appeared on this small planet Earth. There would be no sky, no ocean, no fields, no forests. Nothing but barren rock revolving in an airless void. But the questions are there. Because they are there, man will answer them. For of all his creatures, God has given only man the curiosity to ask why, and the spirit to find out why, and the reasoning power to understand why. It's an old problem, very old indeed. In the book of Job, we find these words: Hath the rain a father? Or who hath begotten the drops of dew? Old questions, yes, but asked because God knew that one day man would eventually resolve them, not for conquest, but so that he could live hand in hand with nature.
I wish I'd known centuries ago how you felt about me. Hand in hand. Yes, that would be nice. Mr. Zionist, would you... A woman could never ask this, but certainly a goddess can. Would you marry me?
Meteora, the fact is I am married.
Hey, Doc.
Yes?
You said it couldn't storm tonight, didn't you?
Yes, I did.
Just what do you call that? Doc, I think your isobars have slipped.
Thank you, Mr. Zionist. It was amusing.
The Bell Telephone System takes pride in bringing you this program and its series of shows on science. We acknowledge our gratitude to the distinguished Board of Advisors covering the broad range of modern science: biology and genetics, medicine, bacteriology and botany, chemistry, geophysics, physics, anthropology, mathematics, engineering. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.